Hello, this is MEI Further Maths Core Pure. We're in the second complex numbers section and on the first video on introducing the Argand diagram. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. Let's think geometrically. What happens when 1 is multiplied by -1? On a standard number line, you get this. You could consider it to be a reflection in the y-axis, but you could also consider it to be a rotation of 180 degrees about the origin. In that case, what might multiplying by the square root of -1 do? You'd need to do this twice to get a multiplication by -1. So we're looking for a transformation which, when repeated, would give a 180-degree rotation. So perhaps a 90-degree rotation would do the trick. Let's see what this looks like. Of course, the square root of -1 is I, and 1 times I is I. So that means that the point at the end of the red arrow now is I. We seem to have created two axes, a real axis and an imaginary axis, and we call this the complex plane. They work just like x and y axes. Here's the complex number z1 equals 3 plus 4i. It's plotted on the Argand diagram. The real part of z, 3, is the x-coordinate, and the imaginary part, 4, is the y-coordinate. We can think of it as a point, or we can draw a line and consider it to be a vector. When we start looking at complex numbers geometrically, we can see all sorts of interesting patterns. Let's look at complex conjugates. I've got the complex number z equals 4 plus I. Its complex conjugate is z star equals 4 minus I. Both of these points are plotted on the Argand diagram. What do you notice about the position of z star relative to the position of z? Can you generalise this? I'll leave that as something for you to think about. Let's look at addition. I've got two complex numbers here, and they're plotted on the Argand diagram. If I add them together, I get 7 plus 6i, which is also now plotted on the Argand diagram. If I think of z1 and z2 as vectors, we can get a vector addition, where z1 plus z2 is the vector z1 followed by z2. We can consider subtraction in the same way. Pause the video for a moment and work out what z2 take away z1 would look like on the Argand diagram. OK, here are the points z1 and z2 on the Argand diagram. And my calculation shows that z2 minus z1 is 5 plus I. On the Argand diagram, if I replace z1 with the vector minus z1, then I can see that z2 minus z1 plus z1 is equal to z2, and I've got a vector addition again. There are more notes on integral on adding and subtracting complex numbers in the Argand diagram. That's the end of this short video. The next video in this series is on representing rotation and multiplication by I.